Hey, thanks for joining. This time we will be making a model that you see here on the screen. It's a sort of demo model. We will be applying quite a few pipe commands on this structure. And let's get started. I hope to keep it short this time. And we need to first open up the Rete Editor. We do that by clicking this button here. And we will be making some points first. So let's just create 3 points. I will do it like this. So point 1, point 2, and point 3. So this will be making a middle wire here on the top. And so the first will be on -13, and then the height will be 6. Then the middle point will be on 3, and the last point will be on 13 and 12. Now I will create a list of these points. And you will see in a minute why we do that. And now we can interpolate the wire between these points. So we go to shapes, wire, via points, and we will click this interpolate method. Now we provide the list of points to this interpolate command, and you see in the background that our wire was created, right? So here we have it. Maybe it's good to also just create the skybox. So we have this blue environment that we had in the script before. Let's also create a grid. And okay, so now it will be a bit easier to understand what we're doing in 3D. So we've constructed this path. Now that we've done that, we need to create a few more lines. So let's create those points by clicking copy command. Let's do it like this. And these points will need to go from -10. The height of the point will be on 0. And the Z will be on -3 for these points. So -3 and -3. And you will see in a minute why I do this. So here as well, -10, 0 on Y, then 3, because it's the other line on the other side. And it will go to 10, and Y is 0, and again Z is 3. So now with this we can create a wire that is going through the points as well, and it's called line. And line doesn't need to take a list, it will just have the start and end point. So we do this, connect the start to the start and the end to the end. And here I forgot to update this point, so let's do this now. And it should be on -3 as well. So you see that I've created now a second line here, and the top line is already here, so that's what we want. And also now we have to create another line for these 2 points here. So now you see that this 3D model begins to resemble a model that we had here in this script, except that we don't have that many points yet, so we will create that now. Also, let's just hide those initial points that we've created so that they don't intervene with what we will do next. So for now I will keep those lines visible, and let's subdivide these wires to multiple points. For that I will use OCCT command. I'll go to wire, and here I will use points by params to just extract multiple points from these wires. And if I connect the line to this parameter, you will see that I'm getting 10 sort of subdivisions in this line. And I will do this here as well. And let's do the same for this line. So now we've created subdivisions, but they are not yet controlled from a single variable, and I would like to do that. So I will create a math slider, so create a number slider component from this category, and I will call it, subdivisions. So now I can also say that I want to subdivide between 10 and 50 max. So maybe it's better to see it that way. And the step of subdivisions will be increased by 1. So if I start on 10, I will see 12, 13, etc. till I reach 50, the maximum value of this component. So let's hide those options for now. And I can connect this component now to this, and to this. So you see in the background we update how many points we get on these wires. Okay, so now that we have this, I will do something that is looking maybe a little bit tricky in the beginning, but the thing is that we have now all these separate lists of points. What I want to do is I want to group these 3 points into a list, then these 3 points, etc. And to do that, I will need to create a list like this of all of these entities. I will also need to flip this list like this, and I will need to flatten this list as well. So this is maybe something that is quite advanced. There are tutorials in the introduction to the Rete Editor that explain why we would need to do that, but the effect is quite clear. So if I now say that I want to create a polygon wire, by clicking right mouse button I can say polygon wire, and here we have it. It just takes a collection of points, and if I just plug it in here, you will see that I've now created those triangles that join the points like this. So you use this kind of regrouping of your points quite often, so it's important to realize how it works. If you want to debug what happens in these sort of situations, you can use this preview data component and just connect it to various parts of this process, so you can check, okay, how the structure looks in this. Then you can just compare it to what happens here, and finally what we end up with. What you see is here that we have like this collection of arrays which contain 3 points each, and now we were able to then plug it into this polygon component to create polygons. Another thing that I will do is I will just round these triangles. So I will say that I want to use fillet 2D command. Because these are triangles, it's quite easy, because I know then the triangle is always flat, right? So this is making this algorithm work just better. And I will use the radius of 0.2 to round these shapes. I will hide the original triangles, and you will see now that our triangles are filleted, so they have these roundings on the corners. This just makes the structure looks nice. And actually, for piping to work correctly, you usually need to round your geometry. And let's go ahead and use a pipe command. So let's go to OCCT category here, operations. Here we have piping, and we will start by using this command, pipe wire cylindrical. So what this does is just takes all of these paths and will create pipes through them. You saw that the algorithm was quite fast. Hey, sorry to interrupt. In case you don't know me, I'm Matas, the founder of Bitbybit. I hope you enjoyed this video, and if you do, please hit that like button and subscribe to our YouTube channel. I also want to offer you a small deal. Because you're watching this video, I assume that you're using Bitbybit platform too. Here's the promo code that will give you a small discount to our silver and gold plans. With these plans, you gain access to our cloud infrastructure, 3D configurators, and other advanced features. Your subscription also helps me develop the content, such as this video that you're watching right now. It also helps me develop Bitbybit platform and keep majority of its features free and open source to everyone. Your support means a lot to me. I hope you'll consider the offer, and let's continue with the video. And we almost reached the point, right, that we've had in the example script. This was quite easy to do, but let's continue and experiment a little more. So I can also say that we can have a different kind of profile. So we have here pipe polyline n-gon, and instead of the circle for the profile, this uses something different. So let's look how that works. Here you see that we've created these pipes that are with corners, and in this case we have like 6 corners. You can control how many corners you have here, so like 5, 4, etc. And also what's nice about it is that you can of course increase the radius if you need to. So this is becoming a bit more extreme maybe. You also will notice that you have to avoid self-intersections in these cases. Maybe the fillets need to be larger, but so far with this radius it does still look quite okay, I guess. I don't really see any issues yet with the model, but you have to be careful. You have to combine the fillets correctly with the radius of the pipes, etc. So that it's all logical. Okay, so let's finish off with some optimizations. Let's make that model look exactly as we had it before in the example. So let's just get back to using 0.1 radius. Let's close this. And important thing to note is that we can use this slider component to increase the subdivisions like this, and you see that we create quite a lot of geometry and we draw that separately. To optimize the drawing, it's usually a good idea to make a compound out of your parts and render them in one go. This is just done for performance reasons. Game engines like to have one mesh instead of having hundreds of meshes that need to be rendered separately. So let's do that. Let's create a list now from these pipes that we've created, and you can check how it works by having this preview data as well in here. So let's see what we did. So you see here that we have an array with just a single level, and everything is here sort of flat, or the flattest. When we create a list, it's sort of two-dimensional array, and with this list we can then provide these shapes to make compound component, and we find it here. We create the compound with this component, and we provided a list. So now if we disable this part, you will see that we are still drawing everything. And if I disable this one, you see that all of the pipes are being hidden immediately. And if I enable it, all of them appear immediately. And that just indicates that we have a single mesh and not multiple meshes. And also what's nice about this is we can then go to draw any async component to just draw it. And we can use some fancier options. So OCCT shape with material this time. Let's use this one. So we can then say that we want to provide PBR material. We create that like this. We connect it to material. Here we can control more granular things like metallic parameter, roughness parameter. We can control this Z offset for faces. And yeah, if we're done with that, we can also see that we want to make edges a bit thinner maybe. Let's see how it looks like. Let's connect this now to the draw component, and let's hide the original. So now you see that we have this blue color. Maybe it's nicer to have something like this pink, a bit whitish, similar to what we had in the previous script. So now we have this geometry that is drawn in one go. It has this metallic effect that is, looking a bit nicer maybe in this situation. So another thing that we're missing is just this circle face on the ground. Let's create that. Let's type create circle face. Let's add it here. Let's make it larger like this. So by default it's just red. But let's also use this draw any async component with some OCCT shape simple options. So like this. You can also find them here in this draw category here. So we have OCCT shape simple options. And what I will do is I will just connect this here, and let's change the color to light blue, for example, like this, maybe a bit more. So I will now create also directional light that will provide us with shadows, and let's do that. Draw directional light like this. You see that it created shadows. I will make them more precise by increasing this shadow map size like that, and I will also increase the intensity of the light. So now we have this beautiful looking model that you saw in the example, and it's also parametric, which means that you can just change, this subdivisions component and everything will adapt. So if you want to have only 10 subdivisions, then it just works as well. And if you want to have 50, that is also solvable automatically without you needing to model anything. And in this case, imagine you need to do that manually. That would be really, really expensive work. I hope you guys enjoyed this tutorial. If you did, please hit that like button, subscribe to our YouTube channel, and of course, I hope you will watch other YouTube videos of Bitbybit. Consider subscribing to the platform. Cheers!